Today we'll discuss nuclear reactions. The term nuclear reaction is used very broadly to describe any wide array of interactions involving nuclei. In a typical nuclear reaction, a projectile A is incident on the target nucleus, and after collision, a nucleus Y and outgoing particle B is absorbed or formed. This may be written as A plus X. After reaction, Y plus B is formed, or generally we written as X open bracket A comma B close bracket Y, where here a projectile nuclear particle A is directed to collide with the target nucleus X. Y and B are the nuclear reaction products. Usually Y is the residual nucleus and is not directly absorbed, while B is the emitted particle that can be detected and subjected to measurement. Nuclear reactions are classified in different types of processes depending upon the nature of collision result. If A is called B and X is called Y, same nuclei and same particle, then the reaction is called elastic reaction. B and Y are in their ground state, that is, the entrance channel and the exit channel are the same. Entrance channel here I mean the projectile and the target nucleus, and exit channel mean the product nucleus and the product particle. In the elastic collision, the projectile and the nucleus collide with no change in the structure of the target nucleus. That means there is no change of energy. No, there is little bit change in the direction, but not the change in energy or the structure of the target nucleus. That type of reaction we call it elastic reaction. The example of elastic reaction is a proton incident on a deuterium nucleus. Again, a proton and a deuterium nucleus is formed. You see this, there is no change this is exit channel and this is entrance channel, this is exit channel. There is no change in the structure of the target nucleus. That means the entrance channel is same as the exit channel here. So this type of reaction we call it elastic reaction. There is a second class of reaction. If A is not equal to B and X is not equal to Y, or if A is equal to B and X is equal to Y, but B or Y or both are in excited state, then the reaction is called inelastic reaction. Here the outgoing particle is different from the projectile. That means A is different from B. That is, the entrance channel and the exit channel are different. Here the residual nucleus has undergone some changes, that is, a compound nucleus is formed. Example of inelastic reaction is alpha particle incident on a nitrogen target, oxygen 17 and a proton is formed. Here you see that the incident particle is different from the emitted particle. This type of reaction we call it inelastic reaction. Many types of particles can be used to bombard a nucleus. This includes neutrons, protons, alpha, and even a photon. When a target nucleus is bombarded with a particle, the two combine to form a compound nucleus. This is written in equation in the form as A plus X, a compound nucleus is formed, where A, the nuclear particle, that means a projectile, X, the target nucleus, C, a compound nucleus is formed. The asterisk indicates that the compound nucleus contains excess energy, called excitation energy. The compound nucleus will rid itself of this excess energy by the release of particle or a photon. As the compound nucleus is in excited state, that is highly unstable. Because of the highly unstable, it will decay itself to get rid of that excess energy. So the complete reaction is then written as A plus X, a compound nucleus is formed, and then because of that excess energy, so this compound nucleus will get rid of the excess energy, and then a product nucleus and a product particle is formed, where Y, the resultant nucleus here, and B, the resultant particle. The following are the examples of nuclear reaction which are a result of the boundary particle target nuclei with a various particle. Alpha particle incident on a nitrogen target. A compound nucleus is formed. This compound nucleus is highly unstable, will get rid that excess energy, and then oxygen 17 and a proton is formed. So if you see that here, this is entrance channel, and then this compound nucleus is formed, and then this is exit channel. You see that the entrance channel and the exit channel are different. So this is one of the example of the inelastic reaction. So after getting this reaction, we can calculate the Q value in reaction. What is Q value? The Q value in reaction is the difference between the mass energy of the entrance channel particle and the exit channel particle. So we calculate the Q value from this equation. Q is called M entrance minus M exit. M entrance means the projectile and the target. M exit means the product particle and the product nucleus. Or it can be written as Q is called Mx plus Ma minus My plus Mb whole bracket into C square, where C is the velocity of light. The Q value can be positive or negative. If you can see from this action, the Q value can be positive or negative. The Q value is the energy released in the reaction. For elastic collision, Q is called 0. That means the entrance channel and the exit channel are same. So that means the mass of the entrance channel and the exit is same. So that's why Q is called 0. In elastic collision, Q is less than 0 or Q is greater than 0. For exothermic or exergic reaction, Q is greater than 0. Sum of the mass energy is converted into the kinetic energy. For endoergic or endothermic reaction, Q is less than 0. Sum of the incoming particle kinetic energy is converted to mass. That means we have to supply some external energy for the reaction to take place in the endothermic reaction. That means we have to supply the energy. Not like in the case of exothermic reaction where heat is evolved. Whereas in endothermic, we have to supply some energy for the reaction to take place. So the Q value of the kinetic energy can also be calculated from this equation. The Q value expressed in the incoming and outgoing kinetic energies. Q is called Kb plus Ky minus Ka minus Kx, where Kb, the kinetic energy of the emitted particle, Ky, the kinetic energy of the product nucleus, Ka kinetic energy of the projectile and Kx kinetic energy of the target nucleus. Normally, for simplicity, the target nucleus is at rest. That means for a fixed experiment, we used to take target nucleus at rest. Therefore, the kinetic energy of the target nucleus is 0. That is, Kx is called 0. Therefore, Q is called Kb plus Ky minus Ka. Again, from this equation, you can see that Q can either 0 or Q may be greater than or equal to 0. Greater than or less than 0. So, after knowing the Q values, we can calculate the threshold energy of the nuclear reaction. What is the threshold energy? The minimum kinetic energy of the incoming particle needed to initiate the reaction is called the threshold energy. The threshold energy should always be greater than the Q values, because a fraction of energy of the bombarding particle must be used to impart momentum to the whole system during nuclear reaction. So we use to express the kinetic the threshold energy. Et is called minus Q Ma plus M capital A by capital A, where M capital A is the mass of target nucleus and Ma is the mass of the projectile.